Here we talk about the V model in the context of system test. The V model is one of the most popular when it comes to system test of embedded integrated complex systems. This is because testing hardware and software first separately, then integrate them, and in the end test the overall behavior is very efficient and effective. The V model is also called verification and validation model, and the structure is depicted as a V shape, hence the name. The V model has two defined dimensions represented by each side of the V shape. And there are three layers of the V model. We have on top the system layer, then the functional layer, and at the bottom the unit layer. The left side of the V shape is the system definition during the development. Requirements are broken down into detailed specification. On top there are the system requirements. Those are functional and non-functional product expectations, safety, performance, and regulatory constraints, and high-level user and product behaviors. Then you have the system design, which is a logical and physical architecture description, a component decomposition, so defining which components exist, and the allocation of functions to those components. And there's the specification design, which is the actual software architecture and the interfaces between the components. Also, the hardware layouts are defined, as well as communication protocols. Also, in terms of specification, the algorithms, state machines, etc. are defined. Then coming to the right side of the V shape. Here the idea is that each layer gets verified on the right side of the V shape. Here, starting from the bottom, you have the unit tests. Those are the tests of individual software components and hardware units. You do requirement tests and software white box testing. This ensures implementation correctness of the actual software code. On top of that, there are the functional tests. These are feature verification and part system verification. Here, the hard and software integration and the test of the interfaces takes place. Also, simulations and part system test infrastructure can be used to enable specific tests. And on top of that, there are the end-to-end tests, which is the validation of the entire system. Use case-based testing and real-life validation takes place here. You also may have regulatory verification, customer evaluation, and safety audits. It is worth noting that the right side of the V-shape represents also the test pyramid with the three distinct layers. And in terms of testing, the V model brings specific advantages. For example, you have the coupling between hardware and software testing, which is especially important for embedded systems. Then you have the systemic test of dependency, which is very important for complex systems where you have multiple components. You cover complex integration of components due to the layered approach, and there's a high coverage due to the three layer. So as a conclusion, it is to say that very rarely you have only the V model in some kind of product development. Usually you combine the V model with other development flow types at specific layers. For example, for writing the actual software, you can combine it with incremental and iterative approaches. This also mitigates some of the downsides of the V model, which can be relatively slow with long feedback cycles. By allowing agile development flows for individual teams of each layer, these downsides can be mitigated.